So our work really has stemmed from a very strong interest and study of the human placenta using animal models as well as human placental tissue. And we and others have shown that first trimester placental development strongly influences pregnancy outcome. But when women are pregnant, particularly when they're pregnant for the first time, in developed countries, they are blissfully ignorant of the fact that there are a number of complications of pregnancy that they may suffer. The four that I'd like to talk about are preeclampsia, where the mother's blood pressure goes up and her kidneys don't function well, preterm birth, intrauterine growth restriction, and gestational diabetes mellitus. And these four complications of pregnancy surprisingly affect up to 1 in 4 pregnancies in Australia and other developed countries. And all of these impact the health of both the mother and the fetus during pregnancy, but may have, or are shown to have, lifelong health effects in both mother and child. So we've been spending probably the last 10 years trying to develop tests that could be used in the clinic early in pregnancy to predict which women are at risk of developing these complications of pregnancy. We've been doing a number of other things you can see here, but the ones in purple are our major focus, but I'll just talk today mostly about the development of our screening tests. So to do this, you don't need to read all the detail here, but we undertook the study of a large cohort of pregnant women. We recruited nearly 1,200 women in Adelaide, but we're part of an international cohort, and we collected information and biological samples from over 5,600 pregnancies in Adelaide, Auckland, in 3 centres in the UK, and in Cork in Ireland. And we have a fantastically well-curated database. And with the data and the biological samples we've collected, we've been able to develop these tests that I'll talk about shortly. But first of all, just as outcomes for pregnant women in developing nations are quite different from those in developed countries, there are also inequalities within developed nations. So just here, I've got the outcomes. These are pregnancy outcomes across the top of this table. Non-cases, the women who had uncomplicated pregnancies, then we have preeclampsia, gestational hypertension, gestational diabetes, small for gestational age, and spontaneous preterm birth. And you can see in red here, the women recruited here in Adelaide at the Lyell McEwan Hospital, which serves a very socioeconomically disadvantaged population, have much poorer outcomes than any of the other centres. So here's New Zealand, which probably has the best outcomes in this international cohort. You can see here the non-cases. So we only had about 66% of our women in Adelaide who had completely uncomplicated pregnancies, compared to much higher numbers in these other centres. And you can see the outcome of preeclampsia. We had 8% in Adelaide compared to around 4% or 5% in the other centres. And we can go on right across with all these outcomes that the women in Adelaide fared much more poorly than the women in these other centres. All of them, I should say, are predominantly Caucasian in each centre. So what could be different about these populations that might increase their risk for poor outcomes? So here we have very similar tables showing maternal BMI. So this is the BMI when women became pregnant. And these are the BMI categories. Here is the category that we consider normal or lean BMI. And here are the women who are obese in these categories here. And you can see again in red, the Adelaide women were completely different in their BMI to the other women in the other centres. You can see that particularly women who were overweight or obese comprised about 57% of our population in Adelaide, compared to around about 39% in the other centres. And you can see that this reflects in their outcomes. So this graph here shows again the same pregnancy outcomes. Here is the normal range of BMI, and for all of these adverse outcomes of pregnancy, the average BMI of women at the beginning of pregnancy was in the overweight range, with a very significant difference. So also socioeconomic status was different across these populations, and again you can see here in red in Adelaide we used a scale that we could use across all of the different centres, a scale of 10 to 90, with 10 being low socioeconomic status and 90 being the highest. And you can see here these centiles here. So this 10th centile means the bottom 10% of women. The 90th centile means the top 10% of women, and here's the median. So you can see in our Adelaide cohort, the top score for our women was 45 compared to around about 60 in the other centres. So our women in this Adelaide hospital are much more socioeconomically disadvantaged than the other populations. But also that translates into the sort of things that women eat. And we have shown, and others have shown in this large cohort, that eating fruit in the month prior to pregnancy and in first trimester, eating green vegetables in the month prior to pregnancy and during first trimester is very protective against these adverse outcomes of pregnancy. So you can see here this is fruit greater than or equal to 3 pieces a day. Just look at the difference. In the Adelaide women, we have just under 16% of women who have 3 or more bits of fruit a day, compared to nearly 55% in the New Zealand women and slightly lower numbers in the other centres. And then again for green vegetables, eating 1 or more serve of green vegetables, that could be as simple as a piece of lettuce in a hamburger, that was protective. But you can see in the Adelaide cohort, 27% of our women were eating 1 or more serves of green vegetables a day, compared to 56% in the New Zealand cohort. But also the other centres in the UK and Ireland have lower amounts of green vegetable intake. Cigarette smoking. We know that on average a baby who is born to a mother who smokes weighs 300 grams less at birth. And cigarette smoking is also statistically significantly different between our centres. So again in red you can see our Adelaide women. This is the number and percentage of women smoking at conception. You can see that nearly 40% of the Adelaide women were smoking at conception, and by 20 weeks gestation we still had 22% of our Adelaide women smoking, and those women continued to smoke for the rest of their pregnancy. And this compares to as little as 3.8% in the New Zealand cohort of women continuing to smoke at 20 weeks gestation. And we know that smoking, maternal smoking, not only reduces birth weight, it's associated with spontaneous preterm birth. So we've been looking a lot at also genetic factors that might predict risk, because not every woman who has the perfect lifestyle has the perfect outcome. And so we know that it's obvious that both maternal genes and paternal genes give rise to the genes in the baby. So we inherit 1 copy of our genes from our mothers and 1 from our fathers. And our placenta is also genetically identical to the fetus. So the combination of genes inherited from mum and dad largely determine gene expression in both the fetus and the placenta, and of course that determines how well the fetus can grow and how well the placenta can deliver nutrients and oxygen to the fetus to sustain its healthy growth. But also the placenta is an incredibly important organ. Not only does it provide nutrients, it also secretes an abundance of hormones and peptides into the mother's circulation and orchestrates her adaptation to pregnancy. So the placenta is constantly talking to the mother and essentially telling her what to do. So it's this combination of genes that gives rise to determining the health of the fetus and the placenta, and therefore health postnatally and health indeed of the mother during pregnancy. But these genes don't act alone. So they act in an environment, and that environment includes micronutrients, smoking, as I've mentioned, BMI, illicit drugs, socioeconomic status. So we've ended up developing tests that combine these factors because we know, they affect, I mentioned, placental function and maternal health. They affect the epigenome, which we heard about. So in combination, all these factors can predict risk and influence the outcome for both mother and baby. Even there is inequality between male and female fetuses. So we know that male babies are more likely to be born very early preterm, for example, than female babies. But female babies are more likely to induce preeclampsia in their mothers with early onset, so early preterm. But also male and female babies are a different weight at birth. So this shows a graph. This is across all the gestations of these 5,600 babies. At every gestation, boys were heavier than girls. And what might explain that are global gene expression differences in the placenta. So we undertook a study where here you can see this circle represents all the chromosomes. So all these numbers are the chromosomes, and here's X and Y. And these are all genes on those chromosomes, and all the red dots are the ones that are different between male and female placentas. And these are actually a set of normal male and female placentas. So the mothers were healthy, the babies were healthy. And we showed that 142 genes were differentially expressed. Some were upregulated in the presence of a male fetus, and some were upregulated in the presence of a female fetus. So the male and female fetus even are not equal. And these differences in gene expression in the placenta may explain differences in outcome for males and female babies, but also differences potentially in long-term health. So I mentioned we've been developing these tests, and we are the first in the world, in fact, to develop tests for 4 complications of pregnancy that could be used in late first trimester or early second trimester. And we've used a very novel approach where we've come up with combinations of factors. There are clinical factors, lifestyle factors, genetic polymorphisms here we call SNPs, so they're just slight gene variants that change function of genes, and also family history. And in this first part of our test, we take a blood sample from the mother and the father, and we genotype for some of these gene variants. We put them together, the information together with clinical and lifestyle factors, and we find that women with certain combinations are deemed to be either at risk or at low risk of developing the particular complication. And then we put the women who were at risk through another test, which is just done basically on the computer. We don't have to take any blood or anything like that because we've already done it. And these, again, we have another combination of these clinical, lifestyle and genetic factors. And together they then divide the women at risk into those at high risk or those at moderate risk. And this would be incredibly useful for the clinician who, particularly when a woman is in her first pregnancy, so with no previous history of a pregnancy complication, the clinician would like to know which women are at risk. So this simple test identifies those women at high risk, which then allows the clinician to intervene to prevent the pregnancy complication or at least reduce its severity. So this test is quite simple. We need to measure just 25 maternal gene variants in her blood to capture all 4 complications, and we measure 11 in the father. Yes, dads do matter. They do contribute to outcomes, particularly actually preeclampsia and intrauterine growth restriction. The maternal genes are associated with all 4 complications, but for preterm birth and gestational diabetes, it's just maternal genes that are involved. So we also need to know clinical and lifestyle data, and these are all available at 12 to 15 weeks of gestation. And in our estimation, certainly our data suggests that about 32% of women would be deemed to be at high risk and therefore eligible for some sort of preventive intervention. And over 30% of those women actually go on and develop a pregnancy complication. So those women then would have been eligible for an intervention, but also they would have received much more close monitoring from their clinicians so that when things start to go wrong, they're picked up early. And so the severity of their illness and that of their baby would be reduced. So we're currently validating these. I should have said these models have been developed in the Adelaide and Auckland cohorts, and those are actually at the extremes of our population differences. So the Adelaide women had the lowest socioeconomic status, etc., whereas the New Zealand women had the highest socioeconomic status, had better diets, didn't smoke, that sort of thing. So we're validating them now in the UK and Irish pregnancies, and we've also started a new study called Screening Test to Predict Poor Outcomes of Pregnancy, or STOP. We're currently recruiting at the Lyell McEwin Hospital, and shortly we'll start at the Women's and Children's Hospital. Thank you very much.